Somewhere above Europe right now, the jet stream has folded itself into a shape meteorologists genuinely dread seeing form. It's called an omega block, named after the Greek letter it traces across the sky, and it just locked an entire continent under a dome of trapped, rising heat. This isn't a rare curiosity buried in a textbook. It's already killed thousands of people this year alone, and the mechanism behind it is something every single one of us should understand. Let's start with what an omega block actually is, because the name sounds abstract and technical until you actually see the distinctive shape it forms overhead. Once you know what to look for, picture the jet stream, that fast river of wind steering weather systems across entire continents, suddenly bending itself into a massive arc. A ridge of high pressure gets wedged directly between two areas of low pressure sitting on either side of it, and when you map that configuration from above, it traces the exact curve of the Greek letter omega. That's not a metaphor, it's a literal visual match on satellite and pressure charts alike, and it's exactly how the pattern earned its distinctive name among meteorologists who track it every single summer. Under normal conditions, the jet stream flows in a relatively smooth line from west to east, constantly pushing weather systems through a region and moving them along within a matter of days. Rain comes, rain goes, hot spells build and break. That constant motion is what keeps most weather bearable. An omega block disables that motion entirely. Instead of pushing weather through, the jet stream bends around the high pressure ridge and effectively locks it in place, trapping the exact same conditions over the exact same geography for days, sometimes for weeks on end. This year, that mechanism produced genuinely catastrophic results across Europe. Beginning around the 20th of June, a dome of high pressure settled over the continent and simply refused to move, then reloaded itself again in July for a second devastating round. France logged its highest temperature since national records began in 1947, with the mercury hitting 44 points, 3 degrees Celsius. More than 40 people drowned across the country in a single week while desperately seeking relief in unsupervised rivers, lakes, and canals. Thousands of homes lost electricity as power grids buckled under the strain of air conditioning demand they were never designed to handle. The death toll from that June heatwave alone has been staggering to confirm, and the numbers kept climbing higher each time officials revised their initial estimates. France officially reported over 2,000 excess deaths tied directly to the heat, the country's highest heat-related mortality count since the catastrophic summer of 2003, an event that killed more than 70,000 people across Europe. A preprint analysis from researchers at Indiana University estimated the continent-wide toll for just 1 week of that same June heatwave, the week spanning the 22nd through the 28th, at more than 20,000 deaths. And the heat didn't stop at France's borders. Germany recorded a temperature of 41.7 degrees Celsius, a reading that would have sounded almost unthinkable a generation ago, arriving this early in the summer. Weather services across Germany, Poland, and the Baltic states issued red alerts for extreme wildfire danger as erratic winds combined with tinder-dry conditions and scorching heat. Major wildfires burned from Portugal through Spain and into southern France, fed directly by the same locked-in high-pressure pattern sitting overhead. By the time the UK's third heatwave of the summer peaked in mid-July, the Met Office confirmed a record 8 consecutive days above 34 degrees Celsius, a total that beat out the previous records set in both 1976 and 2020 combined. 2026 also became the first year in the entire UK temperature record to reach 35 degrees Celsius in May, June, and July, all within the same single year. Every one of these records traces back to the same underlying mechanism, an omega block sitting stubbornly overhead, refusing to let the Atlantic's usual rain-bearing systems break through. So, why does this specific configuration produce such extreme sustained heat, rather than just an ordinary warm spell? It comes down to what's physically happening underneath that high-pressure ridge. Sinking air compresses as it descends, and compressed air warms, with no incoming weather fronts to disrupt that process, and clear skies suppressing cloud formation. Almost entirely, the sun simply keeps heating an already warming surface day after day, with nothing available to interrupt the cycle. Meteorologists sometimes describe this effect using a simple, memorable image. The high pressure behaves like a lid clamped over a pot, trapping heat that keeps building with nowhere to escape. Making matters considerably worse this year, the specific position of the block over Western Europe allowed hot, dry air to be pulled directly off North Africa and funneled straight across the Mediterranean into the heart of the continent, feeding the ridge fresh fuel day after day. That configuration meant Europe wasn't simply baking under its own homegrown heat. It was actively importing some of the hottest air on the planet and trapping it in place for weeks, reinforcing and intensifying the pattern the longer it persisted. It's genuinely important to understand that omega blocks themselves are not a brand new phenomenon. Meteorologists have documented and studied this exact configuration for decades, and it occurs regularly across both the North Atlantic and North Pacific in an ordinary year. What has fundamentally changed, according to climate researchers who've studied this specific event, is how these blocks behave once they form inside a considerably warmer climate system than the one that produced similar patterns decades ago. An analysis of this year's heat wave concluded the event would have been virtually impossible without human-caused warming layered on top of the natural blocking mechanism. This isn't the first time a locked-in blocking pattern has produced headline-making devastation either. Back in 2021, an eerily similar mechanism, though technically a slightly different configuration known as a heat dome, settled over the Pacific Northwest region of North America and produced temperatures that stunned meteorologists worldwide. The small town of Lytton in British Columbia hit 49.6 degrees Celsius, an almost incomprehensible reading for a region famous for its mild, temperate climate, before the town itself burned down in a wildfire the very next day. Hundreds of people died across Washington, Oregon, and British Columbia during that single event, with researchers later concluding it would have been statistically almost impossible without the influence of human-caused climate change. The parallel between that 2021 event and this year's European catastrophe is instructive precisely because the underlying atmospheric mechanism rhymes so closely. In both cases, a stubborn ridge of high pressure became wedged in place by surrounding low-pressure systems, disabling the jet stream's normal ability to push weather through and move on. In both cases, the resulting heat proved so far outside historical norms that scientists initially struggled to model how such extreme temperatures were even physically possible under the existing climate. And in both cases, subsequent attribution research confirmed that background warming from greenhouse gas emissions had made an already dangerous weather pattern measurably more extreme and considerably more likely to occur. That distinction matters enormously, because it explains why record after record keeps falling, even though the basic atmospheric physics behind an omega block hasn't changed at all. Each fraction of a degree of background warming pushes the eventual peak of a heat dome slightly higher and makes previous records considerably easier to break. That's precisely why a reading like Germany's 41.7 degrees Celsius, a number that would have sounded genuinely alarming and unprecedented a generation ago, is now something that can arrive during a routine June heat wave, rather than standing alone as an extraordinary once-in-a-lifetime event. If you're finding this kind of grounded breakdown of what's actually driving these headlines genuinely valuable, go ahead and hit that like button. It makes a real difference, helping this channel reach more people who want real context, instead of just another scary temperature map with no explanation behind it. There's also a broader atmospheric factor layered on top of this year's specific event worth understanding, because it helps explain why 2026 has proven so relentlessly extreme across multiple consecutive heat waves rather than just one isolated episode. NOAA has confirmed the emergence of a potentially super-strength El Niño this year, a natural climate pattern that tends to temporarily boost global temperatures on top of whatever baseline warming already exists from greenhouse gas accumulation. When an omega block forms directly on top of an already elevated global temperature baseline being pushed higher still by a strengthening El Niño, the resulting extremes compound, rather than simply add together. Understanding how an omega block typically breaks down is just as important as understanding how it forms in the first place, since that breakdown point is ultimately what everyone living underneath one is waiting for. Most of these patterns last somewhere between 3 and 10 days before natural atmospheric variability eventually disrupts them, though, as this year has repeatedly demonstrated, some persist considerably longer, particularly when reinforced by additional factors like unusually warm ocean, temperatures, or a strengthening El Niño sitting underneath the entire system. Breaking the pattern typically requires the jet stream to shift back toward its normal, faster-flowing configuration, which allows the low-pressure systems that had been locked out on either side of the block to finally push through and displace the trapped, stagnant air mass. For anyone currently living under conditions like these, or watching a similar pattern develop wherever you happen to be, there are practical steps worth understanding regardless of the specific mechanism driving the heat. Extended blocking events pose their greatest danger not through a single hot afternoon, but through the cumulative toll of consecutive days and nights without meaningful relief, particularly for elderly residents, those without reliable air conditioning, and anyone with pre-existing health conditions that make heat regulation considerably more difficult. Checking in regularly on vulnerable neighbors and relatives throughout an extended heat event matters more than almost any single precaution you can take on the hottest individual day. Avoiding open water during extreme heat is worth emphasizing, specifically given what happened in France this year, where more than 40 people drowned in a single week seeking relief from the temperatures. Rivers, lakes, and canals that seem inviting during unbearable heat often carry currents, sudden depth changes, or cold spots far more dangerous than they appear, and emergencies. Services consistently report a sharp spike in drowning incidents during exactly this kind of prolonged heat event. Sticking to supervised swimming areas, never swimming alone, and respecting posted warnings become considerably more important precisely when the temptation to cool off anywhere possible is at its strongest. At the end of the day, an omega block is a genuinely dangerous atmospheric configuration precisely because of what it takes away rather than what it adds. It doesn't just bring heat, it removes the entire mechanism that would normally break that heat within a matter of days. When the jet stream locks into that distinctive shape, it's effectively switching off the atmosphere's natural reset button, leaving whatever conditions happen to be sitting underneath it to intensify, day after day, until something powerful enough finally forces the pattern to give way. That's also why meteorologists across Europe kept describing this year's event using increasingly urgent language, as June turned into July, watching a pattern that would normally have broken down within a week or two, instead reload itself and push into a second devastating round. The longer an omega block persists, the more the damage compounds, not just in terms of peak temperatures, but through drought stress on agriculture, strain on power grids already operating near capacity, and cumulative health impacts that continue building even after any single day's headline temperature starts to fade from the news cycle. If you want to keep tracking exactly how this pattern develops, along with the real science behind every extreme weather headline before it becomes tomorrow's viral clip, subscribe to the channel so you never miss an update. Stay cool, stay safe, and I'll see you in the next one, ready to break down whatever the atmosphere decides to lock into place next.